In September 2014, ISRO made history by reaching Mars on its very first attempt with a budget of just $73 million, cheaper than the Hollywood movie The Martian. The mission was so efficient it cost less per kilometer than a cup of tea in India. But why Mars? Why did ISRO choose Mars when there were so many other priorities? How did they achieve this extraordinary feat with the limited time, resources and technology? And how did this mission change India and the world? Movements of pride are born from great vision, and the Mars Orbiter mission MOM, lovingly known as Mangalyaan, is one such story. On 15th August 2012, Prime Minister Manmohan Singh officially announced the mission, marking the beginning of India's remarkable journey to Mars.
अभी हाल ही में हमारी कैबिनेट ने मार्स ऑर्बिटर मिशन को मंजूरी दी। ये मंगलयान विज्ञान और तकनीक के क्षेत्र में हमारे लिए एक बड़ा कदम होगा।
Mangalyaan was launched on 5th November 2013 aboard the reliable PSLV C-25 rocket. This marked a significant milestone as it became the India's first spacecraft to leave Earth's orbit and head toward another planet. After traveling an incredible distance of 780 million kilometers over 298 days, it successfully entered Mars orbit on 24th September 2014. The spacecraft carried 5 sophisticated scientific instruments, each designed to explore Mars differently. Mars Color Camera (MCC) captured images of Mars surface and monitored weather patterns. Methane Sensor for Mars (MSM) searched for methane and mapped surface reflectivity. Thermal Infrared Imaging Spectrometer (TIS) measured surface temperature and mineral composition. Lyman Alpha Photometer (LAP) studied water loss by analyzing hydrogen and deuterium in the atmosphere. Mars Exospheric Neutral Composition Analyzer (MENCA) analyzed the composition of Mars' upper atmosphere. Mangalyaan's mission objectives included developing technologies for interplanetary missions and studying Mars' surface, atmosphere, and moons. The spacecraft's autonomous system enabled it to function independently during critical phases, such as orbit insertion, where communication delays made real-time commands impossible. The spacecraft had a total mass of 1,337 kilograms, including 852 kilograms of propellant. It featured a modified I-1K structure made of aluminium and composite fiber reinforced plastic. Its power system included 3 solar panels generating up to 840 watts, supported by a 36Ah lithium-ion battery. Propulsion was provided by 440 Newton liquid engine for major maneuvers and 822 Newton thrusters for attitude control. Communication was facilitated through ISRO's Deep Space Network (DSN) in Bengaluru, with additional support from NASA's DSN and South Africa's SANSA during non-visible periods. A high-gain antenna ensured efficient data transmission at the S-band frequency. Mangalyaan's success was the result of dedication and brilliance of a remarkable team of scientists and engineers, including Dr. K. Radhakrishnan, Chairman ISRO, Dr. M. Annadurai, Program Director Overseeing Project Manager, Dr. S. Arunan, Project Director, Dr. Nandini Harinath and Ritu Karidhal, Deputy Operation Director for Navigation, Dr. S.K. Sivakumar, Director ISRO Satellite Center, who conceptualized and realized the spacecraft within 15 months. Momita Datta, Project Manager. This team's collaborative efforts turned visionary idea into reality, showcasing India's scientific and engineering capabilities on a global stage. One of the most remarkable aspects of Mangalyaan was its cost. At approximately 450 crores, $73 million, it was the least expensive Mars mission ever undertaken. Factors contributing to this efficiency including a modular approach, fewer grand tests, homegrown technologies, and long working hours by ISRO scientists. On 24th September 2014, after a series of precise maneuvers, Mangalyaan successfully entered Mars orbit. This included a crucial deceleration burn using its 440 Newton engine over its operational life, which exceeded the planned 6 months to last over 7 years. The spacecraft achieved the following: shoestring captured stunning images of Mars surface, its moon and the far side of Deimos, one of the moons of Mars. Its success inspired future interplanetary missions and cemented India's legacy in space exploration. Why did ISRO choose Mars when there were so many other priorities? Mars stands out as a scientific treasure trove, offering unparalleled opportunities to address humanity's profound questions, such as whether life ever existed beyond Earth. Discoveries like ancient river valleys, water ice deposits, and signs of past habitable conditions position Mars as a natural laboratory for understanding planetary evolution. Its similarities to Earth, such as day length and seasonal patterns, make it an ideal comparative study. Here are some key discoveries we made about planet Mars: water ice in polar regions, evidence of ancient rivers and lakes suggesting a wetter past, the vast Wales Marineris, a canyon stretching over 4,000 kilometers. These findings not only fuel our curiosity but also help us better understand our own planet. A counterpoint often raised questions the expenditure on space mission when pressing issues like poverty persist.
One end of the spectrum, so much of money that is being spent to send a rocket out into outer space, when we know that here on Earth, in my country, there are children dying every day because they have no food to eat.
However, space exploration yields indirect societal benefits. Satellite technology, for instance, aids in disaster management, agriculture planning, and weather forecasting, improving lives globally. Moreover, the advancement in science and technology often find application in healthcare and education. Addressing immediate human needs and investing in the future are complementary goals, not for competing ones. How did ISRO make it possible? The mission epitomized engineering brilliance, cost efficiency, and meticulous planning. Engineering genius, PSLV, Polar Satellite Launch Vehicle, became the backbone of this mission by miniaturing components and adopting the strategy of inserting the orbiter into Earth's orbit before slingshotting it to Mars. ISRO overcame significant challenges with finesse, cost efficiency, achieving the mission on a shoestring budget of $73 million, a fraction of cost of similar missions, demonstrated ISRO's resourcefulness, people power. The dedicated teams of scientists, engineers, and technicians worked tirelessly to ensure success. Their collaborative spirit and innovative problem solving were vital. First attempt success. MOM made history as first Martian mission to success on its maiden attempt, underscoring ISRO's technical expertise and rigorous planning. How did this mission change India and the globe? India emerged as a formidable player in the space industry, showcasing its capability to execute complex missions with unparalleled efficiency. The technologies developed for MOM have staggering benefits, fostering advancement in fields like material science, electronics, and aerospace engineering. The mission inspired a generation of young Indians to dream big.
Very big achievement for India. I mean, we are feeling very proud to be Indian.
MOM highlighted India's ability to collaborate internationally. For instance, the recent Proba 3 mission with ESA demonstrates the strength of global partnerships. Proba 3, aimed at precision formation flying, underscores ISRO's role as a reliable global partner. The mission catalyzed the growth of India's space economy, boosting satellite manufacturing and the launch services. After 8 remarkable years of service, the Mars Orbiter mission sent its final transmission on September 27, 2022, far surpassing its planned 6-month lifespan. Though its mission has ended, Mangalyaan's legacy continues to inspire, reminding us that with determination and innovation, even the farthest frontiers are within reach.
Dream, 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 transforms into thoughts, thoughts result into action.